All right, so our lesson today is called Midsegments in Triangles. So a midsegment looks like a line cutting through a triangle, but we really got to define this because, you could have, a lot of triangles that you might think are midsegments. Let me just show an example. Like if I just have a line going through like that, that's not a midsegment. If I have it going like that through the triangle, that's not a midsegment. So what defines it to be a midsegment? So that is really important. The word mid is coming from the idea of midpoint. And so this point right here is the midpoint of this side and this side. But that still would not be enough to say it's a mid-segment. Like, for example, this one, it looks like it could be the midpoint here and here, but definitely not the midpoint on this side. This is not the same as this side. That's not a mid-segment then. So not only does this need to be the same in the midpoint, but this point also needs to be directly in the middle of this side. Then you can connect those points, which, it's a little harder in digital learning to convey this message. I wish we could draw it and kind of play with it with measurements and stuff like that. But it's got to be drawn from finding the exact middle here, that halfway point. Then connect and you have the midsegment. So let me just make a note that's like if the midpoints of two sides are connected. So the midpoint here and here are connected. Then the midsegment is, and then here's what we can learn from this midsegment. This, if you can notice, this line is exactly running parallel to the bottom. So I will have parallel lines. So one thing to note is the midsegment is parallel to its base. So this line and this line are parallel. But maybe more importantly is that the midsegment, this length you can see of the midsegment is much shorter than the length of its base. It's always going to be shorter. But it's not just randomly shorter, it's exactly half of its base. So the midsegment is 1/2 of its base. Now let me put that in an example here. I don't need to do that. For this case, if I was to set this up, I could say that DE equals BC. Well, that's not true. This length is not equal to this length. To make them equal, I would have to double the midsegment. Double this length would give me this length. So that's one way of doing it. Or I can do it like this. I can say DE equals BC. That's not true. That's not equal to that. But if I took half of that, then it would be equal to that. So I can put the half on the BC and have that, then half of that would be equal to that. So this is really key here. Let me just quickly show an example then with that. Is like if I had a midsegment, that means I find the midpoint here and here. I find the midpoint here and connect. Now I have a midsegment. So let's say this was X and this was 12. What would X be? Half of the base here, so 6. If I go the other way around, let's say I have a midpoint here and here. This is a midpoint here and here, and connect. And let's say the X is here, and then this, let's say, is 40. Well, if that's 40, that's the midsegment, then this would be double that length. So x would be 80. So that's kind of the idea. Let's go ahead and try some practice.